sampling. So sampling is when we perform an experiment a number of times and record the results. And in order to do sampling, we're going to need a few different formula. We're going to look at the mean of a sample, where we denote with x bar. That's going to be the sum of our scores multiplied by their relative frequency. So this symbol here we use for the mean, and this is our score, and that's our relative frequency. Then we have a formula for sample variance, that S squared is equal to the sum of our scores minus the mean all squared multiplied by the relative frequency. So S squared is our sample variance, and the square root of S squared will give us S, and S is actually going to be our standard deviation. So there is no symbol for sample variance, it's just S squared for our sample variance. And we have another formula for sample variance, that's S squared equals the sum of x squared times the relative frequency minus our mean squared. So these formulas are very similar to our probability distribution formulas, and we can use them in almost the same way. So let's have a look at a scenario here. So we've got 4 dice that we're throwing at the same time, and we're going to let x equal the number of dice showing a 6. And I'm going to draw up a table of results of when we conducted this experiment. Okay, so we've got our x values of 0, 1, 2, 3, and 4. So this would be when we roll the 4 dice, having 0 6s showing, having only 1 6, 2 6s, 3 6s, and all 4 being 6s. This we'll use for a sum. Okay, so our frequencies were as follows. So we had 27 times showing 0 6s, 44 times showing 1 6, 24 times showing 2 6s, 5 times showing 3 6s, and no times showing 4 6s out of, so that all sums up to 100, so conducted 100 times. So now let's find our relative frequencies. So to find our relative frequency, we just take our frequency and divide it by the total amount of experiments. So here we get 27 over 100, 44 over 100, 24 over 100, 5 out of 100, and 0 out of 100, which will just be 0. And if you add all those relative frequencies together, you get 1, and that should always be the case. And what we're after here is we want to find our mean, our sample variance, and our standard deviation. So our next step is going to be multiplying our values of x by our frequencies. So we're taking our values of x, multiplying it by our frequency. So 0 times 27 is 0. 1 times 44 is 4. 2 times 24, 48. 3 times 5 is 15. And 4 times 0 is 0. And adding those all together gives us 107. Now, our next step is to multiply our values of x by our relative frequencies. So we're taking this value of x and multiplying it by our relative frequency. So 0 times 27 on 100 is 0. Then we have 1 times 44 on 100, which will just be 44 on 100. Then we have 2 times 24 on 100, which will be 48 on 100. Then we have 3 times 5 on 100, which will be 15 on 100. Then 4 times 0, which will be 0. And when we sum all these up across here, we get 1.07. And this value of 1.07 is our mean. So we've got our mean as 1.07. Our next step is to square our value of x and multiply it by the relative frequency. So first we get 0 squared times our relative frequency of 27 on 100 will just give us 0. Now we've got 1 squared times our relative frequency of 44 on 100 will just be 44 on 100. Then 2 squared, which is 4, multiplied by our relative frequency of 24 on 100 gives us 96 over 100. Then 3 squared, which is 9, times our relative frequency of 5 on 100 gives us 45 on 100. Then 4 squared, which is 16, times our relative frequency of 0 gives us 0. Summing that all up gives us 1.85. And now we're ready to find our sample variance, because we know our sample variance is the sum of x squared times relative frequency minus our mean squared. So sample variance is just going to be, now our sum of x squared times our relative frequencies is right here. So we get 1.85 minus our mean squared, which is 1.07 squared. So we get a sample variance of 0.7051. That's our sample variance. Then finally, to get our standard deviation, we just need to square root both sides. So our standard deviation is just the square root of 0.7051, which will get 0.84 for our standard deviation.